up, we have Harper Kolehmainen, who is a student at Rhodes and was a summer intern here at UTHSC with Shaunak Sen, and she'll be presenting on a interactive application for large-scale genetic data analysis. So, thanks.
Good morning. Like you said, I'm Harper Kolehmainen, and I'll be presenting on a real-time interactive application for large-scale genetic data analysis. So, as I'm sure we all know, there's a big problem with managing computing speed when you're dealing with incredibly large data sets. And as data sets get larger and programs get more complicated, this problem only gets more difficult. And it's really important that we find creative solutions to speed up the processes that are important to us. Although a lot of interactive or a lot of tools and systems exist for performing association scans, one major drawback of many is the runtime and the slow speed. We sought to solve this problem for at least the case of BXD mice by creating Wolf River Interactive, which is a large-scale genetic data analysis tool for BXD mice. So some primary capabilities. We have two versions of the interface, one for single trait scans and one for multi-trait scans. Both provide users with a wide variety of options in an interactive menu. We allow the user to use permutation testing to measure statistical significance. They can input the thresholds, they can input the number of permutations to use. We provide a wide range of data filtration and transformation options as well. And we are compatible with loco methods, non-loco scans, and the use of covariates. If you're running a single trait scan, we will return or plot a QTL plot for you. And if you're doing a multi-trait scan, the result will be an eQTL plot. Well, I'm sure this is a little redundant considering the audience, but just in case anyone does not know, since it's the focus of the program, the BXD mouse family is a recombinant inbred mouse family stemming from the C57BL/6J or B and DBA/2J or D strains, hence the name BXD. And it's a widely used population in biomedical research. So let's go over some implementation details. Our current prototypes are in the form of Pluto notebooks. For anyone who does not know, this is a reactive programming environment for the Julia scientific programming language. Reactive meaning that if you change the value of a variable in one cell, it'll automatically update the value in all other cells. It reacts to what you do as you do it. We also use several Julia packages. Bulk LMM, which is a Julia package for performing genome scans for multiple traits in bulk sizes, or on a single trait with high-speed permutation testing using linear mixed models. It achieves incredibly high speeds through optimization, and methods like multi-threading and methods like grouping by similar heritability to reduce the number of eigen decompositions and transformations that have to be computed. We also use Big River QTL plots for our data visualizations. This is a Julia plotting package designed to streamline data visualization and enhance the process of statistical analysis in genetic studies. You'll hear more about both of these packages, I think, in the next talk. So some benefits of this Pluto notebook implementation. One really big benefit is that it allows interested users or users that are more adept at coding to actually clone the notebooks and make any desired changes to the coding or the computations that are not offered in the interactive menu. It just gives you a wider, more versatile range of options. Additionally, it can be launched in a web browser, so it doesn't require you to actually download an application. Okay, so we're going to go ahead and demonstrate this. We're going to start first with the single trait scan notebook. So in this case, we're going to look at the clinical phenotypic traits for the BXD mice strain level. And here you can input the trait ID for the trait you're interested in. Right now, we're going to look at, say, BXD 1001. The number of permutations is also for you to input. If you would like to filter your data, you can set this to true, and you get a data filtration menu options here. We have several, one being filter by value, where you can choose to keep or remove any samples with a certain value for a certain trait. So for instance, if you're only interested in running an association scan with the female samples, you could set it to keep samples with value female for trait sex. Additionally, you can filter by index, so only keeping or removing certain indices or ranges of indices. We also provide a remove outliers option, where we're defining outliers as anything with a z-score greater than 3 or less than -3. Additionally, we can log transform the data. We can also use loco, and you can input your significance and suggestive thresholds. If it's a clinical phenotypic trait, we also offer a description of that trait from Gene Network. It's this one, in this case, it's a central nervous system morphology trait, which is the cerebellum weight whole, bilateral in adults of both sexes in milligrams. So this, I believe, ends up with 34 samples, this particular example. And the genome data has over 20,000 loci. And if we run this scan, you can see it takes less than 1 second to run. So it's very, very fast. If you want additional information, you can select these options here, which will show you the loci above your 2 given thresholds and give you information on those lot scores. Additionally, we just provide some dot plots and histograms, and then of course the number of samples, because since we have to do some data processing to deal with missing values, the initial size of the data set is not going to be most likely the size it ends up being when we run the scan. For the multi-trait notebook, in this case, I'm going to go with the spleen mRNA data set. And in both cases, the single trait and multi-trait, the estimation method is up to you. We have RIML and ML. And once again, we can log transform the data. We can use covariates if we would like to. And we specify the log threshold value for the EQTL plot. It also has local options. When we run this scan, it takes, on both of these are running on my personal laptop also. It takes about 21 seconds. And that spleen mRNA data set has over 35,000 traits, with the genome loci being over 20,000 and 79 strains in this case. Okay. Are there any questions?
That's your presentation? Yeah, thank you.
Oh, sorry.
Hi.
Thank you. Last little thing, just acknowledgements. Just wanted to thank UTHSC. This was a project that I did during my summer internship with the Biostatistics Division. And Dr. Sanakson and Dr. Gregory Farage as well, because they were my faculty sponsors during that and were extremely helpful, and of course made the Julia packages that are used. Okay, thanks.
Great, very impressive work. Are there any questions?
I didn't quite understand how you do the editing. The transformation made sense to me. It looked like there was a range. You could say delete cases with values between X and Y, or how does the entry work there?
So I have a lot of helper functions that are doing like all the filtering on the data frames. But in terms of the user inputs, let's see. So the indice range, that's for if you're filtering by index. So you can choose to either keep or remove for either of these. And you could remove certain indices or a range of indices, keep a certain range of indices if you're trying to subset things. And then for this, it's just filtering by value for a specific trait. And you would give the like column ID of that trait.
I got it, but where do you find the index that you want to remove, or the indices that you want to remove? Is there a display of all the values somewhere?
I don't have a display option currently, but that's something I would like to incorporate.
Question in
Yeah,
the back?
are these functions that you specifically wrote for BXD analysis, or could I use this on the CC or an F2 cross?
So that is what is so fantastic about the Pluto notebooks. Currently, the data sets that I have attached to this are the BXD genotypic and like phenotypic data sets. But any data sets that are in that format can be used. They don't have to be the BXD ones. If you were to clone this and this change out the directories of the file paths, you could use any data sets that you would like.
Thank you.
Do you have any other questions, or also online? I think so.